So this episode will be our first look at moles. So moles are a measurement of chemical amounts. So because atoms and molecules are so small, it's really inconvenient to talk about individual atoms. And instead, chemical amounts can be measured in moles. Now, 1 mole of any substance is 6.02 times 10 to the 23 atoms of that substance. That number, 6 times 02 times 10 to the 23, is one you need to remember, and it's called Avogadro's constant. Now, 1 mole of any substance, remember, is 6.02 times 10 to the 23 atoms of that substance. This figure is known as Avogadro's constant. Remember, Avogadro, not to be confused with avocado. Now, the relative formula mass of a substance is equal to the mass of 1 mole of that substance in grams. Now, for an element that is the same as the relative atomic mass, okay? So every carbon dioxide molecule has 1 carbon atom and 2 oxygen atoms. So the relative atomic mass of carbon is 12, and the relative atomic mass of oxygen is 16. So to work out the relative formula mass, we take 12 and we add it to 2 times 16, which gives us 44. Now, the mass of 1 mole of carbon is 12 grams, which is the same as its relative atomic mass, and that'll be the same for any carbon atom. So when we're calculating moles, we need to know that there's a formula. Now, moles is equal to the mass divided by the relative formula mass. So to calculate the relative formula mass of sodium chloride, we have to provide the relative atomic mass of each element, just in case you don't have a periodic table handy. So remember how we work out the relative formula mass. So the relative formula mass is the sum of the elements the sum of the relative atomic mass of the elements times by the number of atoms in that element. So for sodium, the relative atomic mass is 23, and the relative atomic mass of chlorine is 35.5. So to work out the relative formula mass, we need 1 sodium atom and 1 chlorine atom. So that is 23 times 35.5, which is 58.5. Now, if we think about amounts of substances in an equation, so balanced symbol equations can be used to interpret in units of moles. So the equation, an equation shows us, say if we've got 2Na plus H2SO4 goes to Na2SO4 plus H2. What that tells us is that there are 2 moles of sodium that react with 1 mole of sulfuric acid. That's because you've got 2Na plus H2SO4. And it produces 1 mole of sodium sulfate and 1 mole of hydrogen. So that's because we've got no number before the Na2SO4 or the H2. So we know that 2 moles of nitrogen of sodium plus 1 mole of sulfuric acid will produce 1 mole of sodium sulfate and 1 mole of hydrogen. So let's look at an example of that. So how many moles are there in 309 grams of sodium bromide? Now, the relative formula mass of sodium bromide is 103. So remember, the number of moles is the mass divided by the relative formula mass. So if we've got 309 grams and the relative formula mass is 103. We do 309 divided by 103. So the number of moles will give you that is 3. So if we've got the symbol equation, 2Na plus Cl2 goes to 2NaCl, and a chemist has run out of table salt and needs 0.1 moles to make his or her dinner, how many moles of chlorine do we need? So remember the numbers before the compounds in a symbol equation tell us how many moles we need, or at least the ratios of how many moles we need. So if we need 0.1 moles of salt, sodium chloride, then we're also going to need 0.1 moles of sodium, and we're going to need half the amount of chlorine. And that's because sodium and sodium chloride have a 2 before them in their equation, balanced equation, and chlorine does not. Chlorine has nothing, which means a 1, so it's going to be half of it. Now remember, Mr is the relative formula mass, and Ar is the relative atomic mass. Now, which of the following is a measurement of chemical amounts? So elements are not a measurement of chemical amounts, neither are electrons, but moles is a measurement of chemical amounts. So some amounts of substances in an equation. For the equation, 2Na plus H2SO4 goes to Na2SO4 plus H2. That tells you 2 moles of sodium react with 1 mole of sulfuric acid, and that will go to sodium sulfate, 1 mole of that, and 1 mole of hydrogen. So since atoms and molecules are so small, it's inconvenient to talk about them as individual atoms. So instead, chemical amounts are measured in moles. Now, a mole of any substance is 6.02 times 10 to the power of 23 atoms of that substance. And remember what that's called. It's called Avogadro's constant, not to be confused with avocado's constant, which is something very different. So if there were 1.806 times 10 to the 24 atoms of a substance, how many moles would this represent? So remember, Avogadro's constant is 6.02 times 10 to the 23. So there would be 3 moles in that many atoms of any substance.